Hello. How's the audio sounding over there? Great. Love to hear it. So what I've done here, and kind of what I'm working on today, is um, Semfora has a number of tools around like indexing, finding hotspots, finding potentially duplicated code, etc. And a lot of that is actually built out from our indexer itself. So it can find a lot of these things, kind of like a static code analysis tool with its own internal tooling. However, I wanted to also be able to lean on existing tooling and let Semfora automatically parallelize and run linters, tests, things like that. Tests we already have built out for all 26 languages. It will automatically find it'll automatically find test runner. It will run the tests and then give output in the compressed tune format, linking as much as it can to modules and things like that. So we can then backlink it to our internal sharding system. I want to do the same thing for linting in that, there are multiple tools for every language and every library. You can see here we're looking at check style, spot bugs, and PMD for Java, just normal, Java best practices. And on the other side, we are, for Kotlin, we're looking at detect. For JavaScript and TS, we have ESLint or Prettier with a preference for biome now because it's really easy to hook into biomes. Parallelization, it's a hard word. Same with a couple of tools for Rust. The biggest thing is every time we work on something in this code base, we have to build it out for every single language that we like offer support for, and that is it's problematic in a bunch of different ways because the output of each of these tools is also different. So every time we oh hey, welcome. Lilin Manzi. Um, so the biggest thing we have to do is turn it up a little bit. Oh, the volume. Oh, my voice. Turn what up a little bit? The volume of what? My voice or the audio? Or the music? My camera's trying to be funny and keep me cropped out as well. Let's see. There we go. Oh, my voice? Yeah, I can try. Actually, don't know that I can go any higher than this. 1 second. that any better? No, it seems about the same. You can speak. I can add this mic to my hat. How about that? There we go. Is that any better? Perfect. Hopefully that's better, because that's as high as the mic volume goes. But sure. Anyway, so what I was saying is, oh God, what was I saying? Yeah, so every time we have to do something, we have to do it for all different languages. The output's different. So there's a ton of testing that goes into it. And, we always find something as we're building out the beta versions of this. We're always finding something that doesn't work exactly like we expect. So finding new and old projects in every language that we have and continuing to find them as we go is, always super important. For the languages that I work in most often, being JavaScript, TypeScript, and Rust apps, it's really easy for me to even find old projects of my own that are using, 2 or 3 year old versions or even like 5 or 10-year-old versions of linters and stuff like that. But for other ones, we're having to find dead projects on GitHub. Especially for like C#, you think there'd be a lot more, but finding old dead projects in C# on GitHub that still have things like linters that are in those older versions, that's tough. And then getting them to run consistently we're running on Linux right now, but yeah, getting them to run consistently is a kind of a pain. But we're gonna get there. Hello. But essentially what we're doing right now is we are running through, I'm just having Claude pick up a couple of new repositories to test with. So I will usually do that, and then if it can't find anything on the older side, I'll have to manually go and check for the older projects. But yeah, what we have right now is what we call the core 4 for the linters down. The core 4, always the ones that we build out to do initial testing, is always going to be JavaScript, Rust, Java, Python. And then C# always comes next after we use what I call the core 4 across the board. Those core 4 help to build patterns out for any new feature that we're adding for the rest of the 26 languages that we support. So once that core 4 is done, then we go into C#. We're just about done with the core 4 for the Java side. Then I'll start to work on C#, ASP.NET, and then I go back a bunch of versions for ASP.NET. Again, every single feature takes kind of ages to build out this way because we have to make sure they work with all different packages, and then make sure that it works with both the MCP server and the CLI. Though we've done a couple of big refactors in the latest version to make sure that the CLI and the MCP server are always running off the same baseline. So now as we build things out, the CLI and the MCP server are going off the same utility files, which means that if you wanted to say, even though the CLI will always default to like text or JSON output, you could output to the tune format that has been popularized with AI work. But I will go through some examples of the CLI. But again, with so many commands, I can list out the commands in a moment. But with so many commands, the CLI is kind of a beast to run, and it's really meant for SREs that need an air-gapped static code analysis tool that can run, in a server and help them to identify potential bug sources. So they'll be able to index in, let's say, a truly CI environment without having to make any external API calls. They'll be able to search for modules and check for, variable path travels to make sure that, so let's say a variable is getting reset in the middle of your application, you need to figure out where, and it's only happening in CI for some reason. You can track that variable down, find all its use cases, and find all of the places that it's written to. You can run that query locally, or not locally, but in that air gap CI situation. You can run that query, find all the right locations of that, drop a debugger in there, and it should help you to identify the place where the bug is getting introduced. On the other side, which I'll show you in a moment, Semfora really is built for AIs to quickly understand the core functionality of an application and see how it works as they go. So they have what I call layered views, which means that at any point they can detect, they can run that static code analysis and see what the diff looks like as they're going to finish out a project. So they can say, okay, cool, we want to replace every button in this JavaScript application with our new button component, right? So we can go do the static code analysis index, find all of the buttons in the application. That gives you a full list with their location file their file location and their line of code. That one list is heavily compressed as far as like token usage. So think of instead of getting straight HTML out from a grep or a find or something like that, you're getting a compressed list of this is the exact line of code, the module, the parent-child relationships, etc. You get that full list, and then from there you can then start making changes and then run the diff analysis as you go until those two lists are matching, right? And then in theory you could reindex again and pull the list to see if there are any additional buttons that aren't covered. But again, the goal is for the MCP server to allow AI to do those analyses quickly and cheaply token wise. So I guess for again, to better explain it, in a perfect world, assuming that reads or writes don't also need reads, you could disable reads, greps, cats, all that stuff, and rely solely on Semfora to do individual analysis, searching, things like that. But yeah, anyways, back to what we're doing right now, which is, again, we are trying to build out the linting lint tooling for Semfora, because right now it uses a lot of its own internal tools to do code analysis for quality and things like that. But we don't want to leave, we'll call it, leave money on the table. Linters already do a very good job. Static code analysis tools that already exist do a great job. We want to be able to lean on those things as much as possible, and then make sure that they're compressed enough on the output. Let's say if you have 500 things that get responded from like a biome check, you want to make sure that we can compress that output and dedupe and do a whole bunch of other stuff to make sure that AI gets the full list without blowing through the average, say, 200,000 token limit in one conversation, right? You're never going to solve that. And the real solution, I think, always is going to be running these things in sub-agents, which is very, very valuable to do. But in normal reads and working sessions, it's not going to default to using sub-agents unless you force it to, right? And then the other issue is we do automatically reindex as you go, but let's say you have one sub-agent that is writing and another sub-agent that's doing analysis and reporting back, essentially. They're like in a normal, read-write sub-agent situation, it could get out of sync. At least in this way, we could tie things together to make sure that the index is being run regularly. But anyways, I'm doing a lot of talking and not a lot of actually building, so feel free to come ask questions. I'm going to be chilling, and you can't see the actual code window because I'm trying not to expose some of our internal code, but you'll see the other side of things where after I make changes on this side, I will essentially have Claude go and write those changes across to the other languages, just so I have a little bit of control. But there's actually one thing that I'll have Claude do first, which is as we built out the core 4, Claude loves to ignore its own rules and write things out into one massive file. So we're going to code split in the same way that we have for the rest of our code. We're going to get all of the different languages built out for the linter into subfolder. and yeah, we'll go. Yeah. Let me. One thing I've noticed with Claude, Codex doesn't have this issue actually. Funny enough, and Codex is stupid in a lot more ways, which is why even though I pay for both, I tend to lean towards Claude. But during long coding sessions, Claude will forget the tools that it has available to it, and it is quite frustrating. And I have to remind it regularly. Again, the power of Semfora is that it won't forget the code changes that it was working on as easily because it's constantly pulling these things in. But after even after a single context compaction, right, you have to remind it like, hey, you have these tools available to you, and you should do MCP tool searches, right, which it does really well on a brand new chat, but seems to fail on after a compaction. You can see it is running analysis on the lint runner, and yeah, let's see. It even forgets the best way to use these because it should be doing a symbol search here, which the rules are clearly spelled out. But again, Claude probably forgot that tool even existed. My camera decided all of a sudden that it was going to stop tracking my face. I'm not sure why. I know there's a hand command for it, but I can never remember what it is. Google it. No idea if that worked. All right. So while Claude is going up and doing some code splitting there, I am going to start to read some of our lint parsers because I want to make sure that we can compress the output of specifically some of the older C# ones. So what I'm going to be running on the other side is I'll be running both manually running a C# linter and then running it through the output parser and making sure that even weird stuff gets compressed and tied correctly to our shard index. Ooh, I need to get a proper test case for Python's black linter. Could set up a PM service for this, actually. One of the open source pieces of tooling that Semfora, the Semfora GitHub has is Semfora PM. After building it out for my own needs, I ended up realizing that there's another tool that exists that does a really good job of this locally. What is it called? Bubbles or something like that? I can't remember. But essentially the ability to track current work and things like that, almost like a ticketing software locally with an MCP server. Their tooling is really, really good. After I built out the PM, I found them and I did a bunch of tests, and they inspired a ton more functionality that I'm yet to build out into the PM. But I can tell you what Semfora PM does. That's all open source as well. It is one of the only open source pieces that in the graph, since the engine itself is closed source. But the PM is really interesting because I built it initially to have local to we'll call it non-local communication. So every ticket, every what I call discoveries, every plan, etc. So all of those get saved locally to a SQLite folder in the current directory. As well as having the ability to tie any one ticket, sprint, etc., from local data to things like Linear. Right now, Linear is the only one that we support, but eventually Linear, Asana, Jira, etc., give an API key for those things. And then if any one of those assets is tied to remote, it will keep things synced. So if you add something on the remote side, it will sync back down. If you add something locally, it'll sync back up. If you mark a ticket closed locally, it'll close it remote, etc. And then things like the discoveries that are tied to tickets, those can be updated to in Linear, there's one specific type of update. So you can say, okay, cool, we have this one project, right? This project has an update feature. Discoveries are individual things you found out as you go, or individual notes that aren't tied directly to a ticket that has, a set of plans. So like every ticket likely has at least one set of actual working plans that it's not really relevant for the ticket description itself. But think of engineering notes or things like that for your local build. This is really that plan feature is built out. So as AI is going through different compactions and it's doing larger bits of rewrites, it has a much more granular history of the work that needs to be done, the work that it has done, etc. And then as it finds things, or as you find things, you can add these discoveries, which can either be tied to tickets, plans, sprints, projects, features, etc. And those discoveries do not necessarily get pushed up, but you could have them get compressed and then sent up as, not compressed, but get read by AI and then pushed up as a project update. So I don't know. I use discoveries for a lot of things. Like we were in the middle of rewriting our BM25, which is like the word search system, allowing you to do we'll call it like a hybrid symbolic search across your application, saying like, ooh, show me all the auth functionality. It would automatically parse auth to log in, to sign up, user account, blah, blah, blah. It creates this big map of words, so you can do those individual checks. And AI can do checks at a glance without having to know every single component in the application. But it was, as we were figuring out how to do that on much larger applications, I was using discoveries a lot to say like, this one type of parser breaks when you're dealing with a 60 gigabyte application, right? Which I still haven't solved that issue. BM25 does not work anymore with variable parsing. It does not work with Chrome anymore. It went from taking 15 minutes with just the complexity and number of variables in Chromium itself. That 15 minutes that it took to process before, when it was just functions, started to take about 4 hours, which is not great. Thank you. Welcome to the chat. I'm kind of just rambling. Feel free to ask questions about what I'm doing. Right now, I'm just having Claude doing some code splitting for me on linting our linting and lint tooling stuff. But yeah, feel free to ask questions on what I'm doing and what Claude is doing. But otherwise, I can't show you the code for this chunk, at least not directly, because it is all closed source. But feel free to ask questions, and yeah, we'll keep on chilling. Oh, it is. I don't have the latest version up yet, but if you guys would like to check out Semfora in any way. Oh, hi guys. Welcome to the chat. I want to keep on talking programming stuff. Oh, there we go. Ding, ding, ding. I need to use the restroom, so I'm gonna drop the mic here so I don't scar you guys, and I'll be right back. Okay, I'm back. Ish. Dang it. standing outside watching the chat and watching the agent go and do its thing. Well, hi, Lauren's friends. I appreciate you coming to stop by. I'll be sharing the link with some of my friends soon as well. Though again, half of the reason I'm doing this is just to get clips later as I start to explain things a little bit better. All right. So the task that I sent Claude out to do just now was to do some code splitting. So we have our linters and parsers and stuff all. Um, what was I saying? Larry texted me and my brain turned off for a second. Just doing code splitting on the parsers before we write out the rest. We have Clippy, Rust format, ESLint, Prettier Biome, OXLint, TSC, Rough Black, MyPy, PyLint, Golang CI, and a bunch more already. But we need to get more things for C#. Kotlin is in there already, thankfully, because that was one of the big ones. But as I said before, we have what I consider core 4, which is whenever I build out anything, I try to write the first version of that core 4 by hand. And that way, I don't have to let Claude try and figure out the best way to write things. So it can go off of my own functionality initially. And instead of having to figure out the architecture, I found that is easily the best way to ensure that any AI agent doesn't go completely off the rails. But even when I do specify things, I have to get it to go code split because it still likes to, especially after a compaction, still likes to go off and write a 3,000 line file, which is against the rules. music stopped as well. Wonder why. Oh, I still hear it. How did the build succeed if that doesn't exist? Anytime we make changes like these as well, unfortunately, we have to test across, especially when we're making changes to MCP servers. We have to kill everything, restart the, move the build back over to the bin directory, and then test in both Claude Code, Codex, VS Code, Cursor, and everything to make sure that the instructions are properly built out and it knows how to use the tools. Jeez. That's what I thought. I'm gonna restart you. Sorry, folks, gonna have to kill the stream shortly. I gotta figure out when my computer is starting to keel over. I'll be back.